Hey you guys, this is Mr. Sal. Thanks for watching. This is just a quick lesson on, it's really a review for us, but it's on inequalities and also some applications of inequalities. So that means we'll see a few word problems. So thanks for watching. Don't forget to like, comment, and subscribe. An inequality is just a math sentence that compares quantities. Right before we would see a comparison of 5 and maybe -7, and it would eat the 5, something like that, right? But now we're looking at equations, so maybe you got something like x plus 5. We solve these types of equations the same way we would any regular equation, except with one exception, is that if we ever multiply or divide both sides of the equations by a negative, then we need to flip the inequality. And that's just about it, right? So if we see something like negative 3x is less than, I don't know, 60, we would need to divide both sides by -3 if it were an equation. But when we do that, it would flip the inequality, so now that it would be eating the x, right? So x would be greater than -20 in this case. That would be a case where we divided both sides by a negative, but it is possible to multiply both sides by a negative as well. And they'll probably ask us to graph some of these. So when graphing, if we have just greater than or less than, it's an open circle. The open circle indicates that that value is not included in the solution. It is possible that, just like we saw with interval notation, they may have us use the brackets like that, or in this case the parentheses, which also indicate an not included value. If they're closed circles, we would use brackets like these instead of closed circles, okay? But we only use those if it's not only less than or greater than, but also equal to or equal to. And then if it eats the inequality, well, the variable, if the inequality eats the letter or the variable, then the line goes to the right. If it does not eat the letter, then it goes to the left. It's pretty much that simple, okay? And then we'll usually write 3 numbers on the number line, okay? So on that last one, when we saw x was greater than -20, we would have a number line with -20 in the middle, -19 to the right, and -21 here. This one would be an open circle, and it's eating the x, so it goes to the right. So our graph should look something like this. Of course, on the homework, it'll give you the graph. You just put the circle in. And if it wanted it more in a interval type graphing, then we'd use the parentheses there at -20. So here's the problem with that, is if we saw x, well, -20 is less than x. Okay, and that's okay if you do that. Otherwise, and that's okay. But yeah, some people would keep it like this, and then they just make the arrow go to the left. I say to avoid that, but if you do, that's fine. Yeah. Well, this one's nice. We don't really need to solve this inequality. We'll just write the answer as an inequality, which we have, and then we'll graph it. That's great. Let's graph this thing. We will show the interval for this as well. Oh, I didn't see the 3 there. What the heck? It was covered. All right, so I would need to divide both sides by 3. I'm dividing by a +3, so it's not going to flip the inequality. And I've got y is less than 3. So we'll put those values on this number line, 2, 3, 4. This one is only greater than, so it's an open circle. And it is not eating the y, so it goes to the left. So the interval for this, as far to the left as it goes, it will go to -infinity, and then it will stop at 3, which is not included, so we have that other parenthesis right there. It kind of looks like an ordered pair, but it is not. It is an interval. All right, let's solve this one then. So it is a little bit different. And we'll see why here in a moment. To solve this one, I would add 2 to both sides, so that I can get the b's by themselves. I'll drop the negative 6b, which is greater now than 8. But then I'm going to divide both sides by negative 6, which is going to flip. I was supposed to be plus 2, dang it. What the heck is going on here? That's 12. That's going to make that look better. Now divide by negative 6. The dividing by negative 6 is going to flip that inequality. And I've got b is less than negative 2 now. That's better.
How'd you get negative 2? Oh.
So now we'll put this number on the number line. We got negative 2, negative 1, and negative 3. At negative 2, we have an open circle again. And this one is not eating the b, so it goes to the left. All right, same idea on this one. We'll get the y's by themselves. So we'll subtract 5 from both sides. 11 minus 5 is 6, is less than or equal to 3y now. All right, we just dropped that. Then we'll divide both sides by 3, which is positive. That's not going to flip the inequality. 6 divided by 3 is 2. So on my number line, I got these 3 values, 1, 2, 3. And at 2, this one is also equal to the 2, so it's going to be a closed circle. And this one is eating the y, so it goes to the right. So if I were to flip these, I would have y and 2 that I'm comparing as an inequality. But the original one was eating the y, so the new one also needs to be eating the y. So whether you write it one way or the other is not really completely important, except maybe on the homework. But if it helps you with the graphing, then yeah. It just needs to be eating the y still. Yeah, so the interval on this one, it's starting up at 2. It's a closed circle, so it's included. So I'm going to use the square brackets. And how far to the right does this thing go? To infinity, yeah. Which is not included because it is a value that is constantly changing, getting bigger and bigger. We're planning a reception for our daughter. I don't know what the heck is going on here. The hall that we are renting charges a $60 cleanup fee. Okay. In addition to the cleanup fee, they're charging $12 per guest for food and drinks. So just looking for the cost of this rental. You're going to pay $60 up front for the cleanup fee. But then in addition to that, you're going to add 12. And we should specify X is the number of guests or people, whatever. So to find the cost for the guest, yeah, you take the 12 and multiply it by the number of guests, which right now we don't know. Okay. And if we have $2,650 available, what is the maximum number of guests we can invite without going over the budget? So we're comparing the 60 plus 12x with the 2,650. Specifically, we want the cost to be less or equal to than what we have, right? So I want that inequality to be eating the amount that we have. Because the most that you want to spend is how much you have. So it should be eating that, but it's also equal to that as well. Yeah, so to put this a different way, right, is if we were to compare the cost to how much we have, then yeah, the cost would be less than or equal to how much we have. So I guess it's just by the order that I've written it, it's just come out this way. But yeah, we want it to eat how much we have, because that's the most that we want to spend. And from here, now that we have it, we're just solving it the same way that we've been solving these other ones. We'll subtract 60 from both sides to begin with. And then we'll divide by 12 on both sides. That's correct. So yeah, seeing that the answer here is 215.83, you wouldn't, even though for the most, we would think about rounding this up, right? But since we are looking at costs specifically, and X was the number of guests, that means we would have to round this down. Okay, so there's two ways we can go about this. And that would be one of them, is to interpret this as the most. We can put in 215 guests max, but this could also be interpreted the same way if we were to put 216 is greater than x, because now your x, the number of guests, can't be 216, and the next value would be 215. Okay, so whether you write it as 215 is greater than or equal to x, which would be fine, that's okay, but it means the same thing with the 216. This is only the case when we're dealing with values that have to be whole numbers, but really the answer should be written more as a sentence like this. All right, Jim has received scores of 71 and 77 on his first two 100-point tests. That means he got 71 and 77% as well. What score must he get on his third 100-point test to keep an average of 78 or greater? Okay, so we want his scores, and we'll compare that to his, I guess it's his goal average. Specifically, he wants his actual average to be more than, but he'll take the 78 if he can get it, right? So his goal average is actually the 78 or greater, but the lowest he'll go is 78. His actual average right now is 71. He's also got a 77. And then he's got this third test to take, which we don't know the value of it yet. And that's what we'll figure out. To find that average, we would divide those 3 by 3, because there's 3 values. And this has to be greater than or equal to the 78. So, I mean, it's really your choice. I'm going to say let's just add the 71 and 77 first, because we like addition. It's pretty quick and easy. I get 148 out of that. Now I don't want that divided by 3, so I'm going to multiply both sides by 3, so that these will cancel out. Okay. So now I've got, and this is a pretty easy inequality to solve now, and that's the score, or the percentage that he should get on that third test, right? Or the smallest percentage. We'll just subtract 148 on both sides. So x, which is his score on the third test, looks like the lowest possible value he can get in order to average a 78 would be an 86. And judging on his other two test scores, I don't know that that's likely to happen unless these roots, square roots specifically. Square roots cannot be negative. They can be 0 though, which is a radicand is just a fancy way of saying some kind of root. Here's the thing with square roots, okay? Square root is asking us, in reality, if I gave you the area of 25, then what is this? I'm sorry, let me start that over. If I gave you the area of a square, that was 25, so the area is 25. What is the side length for that square? 5. So the square root of 25, which is asking you the same thing, what's the side length of a square with an area of 25? 5. But if I made that a negative 25, well, the side lengths of, yeah, right? The side lengths of a square have to be the same. And if we said, well, the side length is negative 5, negative 5 times negative 5 is actually still positive 25. So it can't be a negative 5. In fact, it can't be anything. This one is considered not real. But it would be not real even if it was just a negative 2, any negative value, right? Because there's no two values that are the same, that when we multiply them together would ever give us a negative, which is why the domain has to be greater than or equal to 0. Now, this may not make a lot of sense right now. It's just meaning that when we see or want to find the domain of a root, all we're going to do is make it greater than or equal to 0 and solve for the x. That tells us all the values, I guess, of x that we could use. So find the domain, same idea, right? We're just taking the root, which in this case is negative 3x plus 8. And as long as negative 3x plus 8 is greater than or equal to 0, all those values will be in the domain. Because if it were negative, then it would be not real, which is not part of the domain. So to solve this, we'll subtract both sides by 8. And then we'll divide both sides by negative 3. So yeah, we did divide both sides by negative, which is also going to flip that inequality. So we do need to flip that so that x now is less than or equal to 8/3. And that would be the domain, I guess. All right, we can put it in, I guess that's set builder notation, something like that. That's the inequality as a interval, because sometimes it will ask for the interval, right, at 8/3. This would be an open circle, and it's not closed circle. Yeah, closed circle. Sorry. Closed circle, it is not eating the x, so it goes to the left, meaning it goes all the way to negative infinity and stops at 8/3, which is included, so it's a bracket. All right, same idea on this one as the last one. I've got x plus 6 in the radical, and it has to be greater than or equal to 0 for this thing to work, right? So to solve it, I'm just going to subtract 6 from both sides, and I get x is greater than or equal to negative 6. So in the graph, it didn't ask us to graph this, but I just show it just because it may be helpful for us to see it on the graph. So yeah, there's an inequality here. This is at negative 6. That's going to be another closed circle. It is eating the x though, so it goes to the right. So the interval starts at negative 6, and this one goes to infinity, which is never included. So yeah, why can we see x as negative 6 here? Is because if I plug it back into the inequality, I'll get something out of it, right? So if yeah, so just to demonstrate it, if I went to the lowest value I can have, which was negative 6, I've replaced the x with negative 6, and then when I add 6, I get the square root of 0, which is just 0. Which is why that works, and that we expected to see 0 because that's the smallest value that we can have. Denominators cannot be 0. I think we've seen that already, right? 1 divided by 0 is 1 divided by 0. And how many zeros can go into 1? Infinite. Yeah. As many zeros as you want. In fact, like we see, you can go to infinity, which is why it's not part of the domain. It's a value that does not exist because it's so big. And it's changing all the time because it's getting so big. So when x is in the denominator, any values of x that would make the denominator 0 not part of the domain. We need to keep that in mind because once we get to polynomials, we're going to see this a lot and in various ways. So we have to be able to skip these numbers in interval notation, which is kind of the trick, even though some of you guys know how to do that, which is great. So on this one, the denominator is just 3x plus 8. In the future, we'll see other x's in the numerator, which will or can change things a little bit, okay? But for now, it's just a 1, so we're not really worried about that 1. Just focus on the denominator for now. So I've got that 3x plus 8. And the inequality is just that it cannot equal 0, which is the domain. Okay, if x is anything but whatever it would be to make this denominator 0, it will work. So I would subtract 8 from both sides. And then divide by 3. So we've got x does not equal negative 8/3. I forget on the homework if they wanted that in that set builder notation stuff. Like this with the the inequality, right? So the domain is x such that x is just not equal to negative 8/3. In interval notation, though, if we were to look at the graph on this thing at negative 8/3, then at negative 8/3 it's an open circle to show that it's not included, but it can be any value to the left or the right. So it goes from negative infinity, it stops at negative 8/3, which is not included, and then we unite this starting at negative 8/3, and this goes to infinity. And that would be the domain in interval notation. Now again, I don't remember seeing it like that on the homework, but you may see it like that in the future sometime. Alright, once again, we're just focusing on the denominator. So 4x minus 19 cannot equal 0. So I would add 19 to both sides. And then divide by 4. So x is 19/4. Maybe they'll ask for, it's not 4.5, but 4.75. If they ask for the decimal. That's not equal to as well, right? So x cannot equal 4.75, and that would be the domain.